This is part 2 in a series of narrated videos to accompany my A-level chemistry speedrun series. So I'm just going to go through each exam question a little bit slower and explain why at each step I did what I did. So this question asks us to work out the final mass of carbon dioxide being produced, and they're giving us the mass of both of the reactants. Now, what that tells me is that this is a limiting reactant question. So not only am I going to have to work out the final theoretical yield, but before I can do that, I'm going to need to work out which one of my reactants is limiting, because that's the one that's going to determine how many moles I make of the product and therefore what mass I make of the product. So the first thing I'm going to do is a little bit of housekeeping, which is that I'm going to look at the question, look at which mass applies to which reactant, and I'm going to write those underneath the symbol equation. And this is because all the time we see people using the wrong mass for the wrong reactant and just getting themselves in a real tangle. So make life easy for yourself and write it down where you can easily see it. Now I'm going to need some relative formula masses. So obviously I can work out the relative formula mass of propane by just adding together the relative atomic masses of all of the atoms in that molecule. And then I can use masses Mr. Mole to work out the number of moles, which here is about 0.45-ish. Now it's really, really crucial that you're not going to round your answer until you get to the very, very end. So I would just keep using that answer button on your calculator. I haven't written out the whole calculator to display here, but you could do that as well. And then I'm going to do the same thing for oxygen. So the relative formula mass of the full oxygen molecule is going to be 32, and therefore I can work out the moles of oxygen I've got. So I've now got moles of both reactants, and this is the time when I'm going to have to look at them and figure out which one is the limiting reactant. Now that isn't as straightforward as just saying, well, which one have we got less of? Because in this particular reaction, they're not reacting in a 1-to-1 ratio. So I now need to look at that chemical symbol equation. And I can see from that they're reacting in a 1-to-5 ratio. So in other words, if I have 1 mole of propane, I need 5 moles of oxygen. If I have 10 moles of propane, I need 50 moles of oxygen. So that's what I'm looking for. So I'm just going to take the propane because I did that first. And if I've got that many moles of propane, I'm going to need 5 times more moles of oxygen. So I'm just going to multiply that number by 5 and say, well, how many moles do I need? And then I'm going to compare it to how many moles of oxygen do I actually have. So here you can see the number of moles of oxygen that I need for the number of moles of propane that I have is more than the moles of oxygen I actually have. There isn't enough oxygen to do the reaction. So that means that oxygen is limiting. And that's really, really important because we're always going to use the limiting reactant in order to work out the theoretical yield. So at this point, I know oxygen is limiting. Oxygen is the one that I'm going to go for. So back to my symbol equation. If I have 5 moles of oxygen, then I need 3 moles of carbon dioxide, or rather I'm going to produce 3 moles of carbon dioxide, I should say. But I don't have 5 moles, I have 2.1875 moles. So in order to figure out how many moles of carbon dioxide that is, firstly, I need to divide by the coefficient in front of the thing that I'm looking at. So I have oxygen and I'm trying to work out my carbon dioxide. The coefficient in front of oxygen is 5. So I divide by 5, you can see that in red here. And then I need to multiply by the coefficient in front of the thing I'm trying to make, which here is my carbon dioxide. So I divided by 5 because that was the coefficient in front of oxygen, and then I multiply by 3 because that's the coefficient in front of carbon dioxide. And that gives me 1.3125 moles. So I go back to my masses Mr. Mole equation, but I don't actually have an MR of carbon dioxide yet. You probably know by now that it's going to be 44, but we should show our working anyway. And then I can then do that multiplication to get 57.75 grams. And in this particular question, they haven't asked for a specific number of significant figures, but I can see that in the question, both of the masses they've given me are to 3 significant figures. And therefore, it's a good idea for me to leave my answer with 3 significant figures as well, just in case there's a mark for that. So I'm going to do a little bit of rounding and make this 57.8 grams. Thanks for watching, and if you are finding these videos useful, then don't forget to like and subscribe for more A-level chemistry coming soon.